Essentially, the brain of a modern human is turning into a plastic waste bin, the equivalent of an entire plastic spoon. That's roughly the amount of microplastic in our brains. The concentrations we saw in the brain tissue of normal individuals, who had an average age of around 45 or 50 years old, were 4,800 micrograms of plastic particles per gram, or 0.48% by weight. That would mean that our brains today are 99.5% brain, and the rest is plastic, explained Matthew Campen, lead researcher from the University of New Mexico. How does our body respond to such an invasion? Nanoplastics, penetrating the blood vessels of the brain, trigger inflammation of the inner vascular lining, the endothelium. When inflammation occurs, the blood-brain barrier becomes more permeable, making it easier for various pathogens like viruses, bacteria, and microplastics to enter the brain. Immune cells engulf these foreign plastic particles, but since plastic doesn't break down, it causes these cells to deform and increase in size. Accumulating in the brain's small blood vessels, they contribute to the formation of microthrombi, which disrupt blood supply and microcirculation, increasing the risk of stroke even at a young age. As a result, nanoplastic particles impair the supply of oxygen and nutrients to brain cells, leading to chronic hypoxia and the gradual death of neurons. These processes drive neurodegenerative changes, including brain atrophy, which, with prolonged exposure,